Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be checking out another one of your guys' solar systems. So today's system is from the user Italian Jesus in Discord, so massive thank you to them for sending in their system. Their system is called the Sulfur System. So without further ado, let's get into this. So there it is, ready to rock and roll. Okay, here we go. Right, here it is. Okay. Oh, where's our description? It's a bit of a bug at the moment. I think you have to keep reopening the sim to get the descriptions, which is a bit bizarre. Let's try again. Oh, and what do you know? It just appears. It's a bit of a weird bug going on at the moment. Yeah, very, very strange. Right, anyway, so this is my first custom system. I went for a semi-realistic look and every object has been customized in game, so no crazy looking objects, okay? Also, English is not my first language, so sorry for any mistakes, no problem at all. I've also used a new description feature to write the meaning of the names in the objects. The system is runnable as well. We do like that. That is good stuff. And also, everybody, don't know if you just heard, but just as a disclaimer, there's a bit of audio, maybe a bit of background audio. I have to have my window open now as we're entering the summer. My room gets too hot and there is a road nearby, so I do apologise if you do hear any background audio. I'll try my best to edit it out. If you do hear anything, I'll watch it and just make sure. But yeah, just take that as a disclaimer. It's hot and I can't film with the window shut anymore because otherwise it gets really hot in here. Right, anyways, let's rock all on. So here we go. So it gets its name from sulfur, so Sulfur System, as it's unusually abundant in the system. Most of life in the system is very different from life on Earth, as it had to evolve on sulfur-rich worlds. This system sits in a nebula and has a subsystem orbiting it, as well as 2 asteroid belts. Alrighty. Interesting. Okay, nice. So where are we heading next? So the star itself, there it is. We turn the goggles off, you get a very bright look at it. So, there it is. A B8 main sequence star. It's very luminous at 100 times the luminosity of the sun and also bigger, with 3 times the mass and twice the radius, as you can see. It's looking pretty menacing. There you go. 100 luminosity, as you can see. So, pretty big habitable zone around this guy. Right, next up we got Ardor here. I like the way the menu, or I like how it's individual for each planet with the menu here. That makes it so much easier to go through, which I like. I mean, I would recommend that everyone does this, because this makes navigation way better. But yeah, here it is. So Ardor, the closest planet to the star, a scorching rock with an average temperature of nearly 1,000 degrees Celsius. There you go. If you turn the goggles off, it's looking pretty bright. So there you go. Oh yeah, the glare of the star. Oh yeah, looking good. Okay, very nice. There it is. Okay, moving on. So we've got Difax next up. Here it is. Difax. A Venus-like planet. Its tidal locked to its host star, meaning it reaches 850 degrees Celsius on the day side and around 75 on the night. On the night side, there are oceans of sulfur dioxide and water, the colours transitioning from blue to orange as the 2 elements mix. Very nice. Okay. Let's have a look underneath the atmosphere as well. There you go. There it is. Looking pretty scorched. If we look on the old map here. Oh yeah, look at that. Ooh. Pretty crazy. Okay. Very nice. Next up, we've got tepid Levita. Oh, am I missing stuff as well? Does it say anything in there? Oh, yeah. Oh, okay, so I missed the first one. So, Ardor, the name, it means heat, flame, burning fire. Anything on the star? Sulfide, okay. And then Difax is two-faced because of the tidally lock. I like it. That's cool. Name meaning. That's cool. I like that. Right, so next up we've got this one. It means slightly warm. Tepid Levita. So there it is. It's an ice giant. Or is it? It gets its blue colours from the abundance of argon, nitrogen, ammonia and methane. It has 1 moon. Nice. Look at it. Very nice and bright with the starlight there. Looking good. So here it is. The moon. Means tidally locked. It's a barren hot rock with a thin sulfur dioxide atmosphere. It is tidally locked, but interestingly to the star and not the planet. That is a very weird. It's a star's pull, just that powerful. That's an interesting concept. So it's not locked to the planet, which is below us. It's locked to the star. I want to run the sim. I want to see that in action. That's a very interesting idea of having the moon tidally locked to the star, not the planet. I mean, is that possible? Well, as we know, space is a place of impossibilities. So, yeah, I like that. That's cool. Right, next up we have this object. Caligul. A small planet with a black atmosphere and the abundance of carbon dioxide, but it also gets a slight blue hue from argon and nitrogen. It has a small moon. It means darkness and fog, as we can see here. Okay, there's the moon. Let's have a look underneath as well. There it is. Nice. And the moon itself, what does that mean? Burnt and scorched. Nice. A hot, desertic and charred moon. It's hotter than its host planet despite not having an atmosphere. Nice, okay. You can almost see, it almost looks like it's glowing from behind. That may just be the background reflecting back on it though, because we've got the red and blue background behind us. But yeah, either way, interesting. Looking good. Next up, we're heading to Terra Theory here. A super Earth, okay. It means almost Earth. A super Earth nearly 6 times more massive than our planet. Okay, it holds a rich ecosystem of very unusual life forms which breathe sulfur dioxide as well as oxygen. Okay, good stuff. The plants have adopted a reddish colour to absorb the light from its blue host star more efficiently. Which has caused the oceans to look purple. It has a small moon and a major moon. Ah, very nice. Okay. So, Terra Theory? I'm completely probably butchering these. I do apologise. So, Terra Theory? F-E-R-E, isn't it? So, looking good. It means almost Earth. Nice. Yeah. Okay, and then the small moon here means sleeping fire. Ignis Sopa. Okay. Yeah, Ignis. This moon was once very volcanic, but now has only occasional eruptions which slowly reshape the surface since there are nothing to erode the material. Okay. So, Ignis Sopa. Okay. Good stuff. Right, and then there's a second moon as well over here. Bruma Aramis. A cold desert world. It holds some water in the north hemisphere. It has orange clouds transporting sand and dust across the moon. It could host life. Okay. Very, very nice. That's cool. So this one again, I'm trying to know what that... Is this a kind of Latin name? Sleeping Fire. Because I've just put those... I wanted to know what language it was. I've just put those words into the translate here, and it's saying it's Latin. It says fiery sleep, which roughly lines up with sleeping fire here, the name meaning. So I like it. Got some proper old language stuff in there. Interesting stuff. I like it. Yeah, there's the moon. Better look at this moon as well. Nice. Interesting. So maybe we have a few different sort of mixes of languages in here, because Terra Theory, is that Latin? I'm not sure. But yeah, that one, yeah, this one here says it's Latin. Nice. I like it. Alright, so moving on. Chorus Spadex. Blue and brown. Nice, there it is. Looking good. The smallest gas giant. It has a small ring caused by a moon being ripped apart. It has a small moon and 2 major moons. Okay. First of them there. Vyrons Spadex. The closest moon. It has a subtle green atmosphere and brownish surface. It's generated from a collision between the host planet and a rogue planet. Okay. And the next moon out. Oh, what does that moon? What does that name mean? Green and brown. So blue and brown. This one is green and brown. This one over here is Frost. It's a small little moon. A small object, mostly covered in ice. It's probably used to be the moon of Gelida before the two were separated by the gas giant. And lastly, we got Gelida over here, which means frozen as well. A captured dwarf planet. It has the same characteristics as Prunia, but is much larger. Okay, nice stuff. Right, moving on. So next up we've got Latus. So it's a big gas giant next. There it is. Looking pretty cool in colour as well. Ooh, I like that. Pretty unique colours. Turn the goggles off. Let's keep them on actually, that's better. Oh, I like the rings. A big gas giant, 50% more massive than Jupiter. It rotates very quickly, completing the rotation in less than 5 hours. Whoa, whoa. It has a big ring system, 2 small moons, and a major moon. Nice. So next up, we've got... Oh, hang on, what does the name mean? I'm quite interested. So this means colourful. Latus. Right, next up, we've got Cavum here. Got a little ring of itself. Nice. Unusual thin hydrogen atmosphere and 11-kilometre deep crater. Ooh. Can we see it here? Is that... Guess it's probably one of those big ones there. Nice. Well, it's a cool view of the planet with the rings, with the moon of its rings. So this says the crater probably generated from the same collision it gave it its ring. Interesting stuff. Okay. Next up we got this one. Tritus. It means beaten and worn. A battered moon. It has over 100 impact craters, so many that many craters have craters inside of them. Kind of like Callisto, Mercury, the moon in the way, some of our solar system's most heavily cratered objects. I think it's Callisto, isn't it? Yeah, Mercury and the moon also have a telltale with the amount of craters they've got. But there it is. Kind of tells you how old a surface of an object is. If the more craters it got, means that technically it's been around a long time without being resurfaced. If we look at this on here, so this is Galas. This means turquoise. 2.5 times more massive than our moon. It has a thick atmosphere of methane and oxygen, as well as oceans made of water and methane. Ooh, oh, oh. Underneath, there it is. Looking good. Oh, that gas giant. Look at the gas giant rings in the distance there. Yeah, there's definitely some kind of reflection with the background lighting, I'm guessing. You can see that there. Turn the goggles off. Can't see them at all. Turn them on. You see everything. Hey. Right, next up. We've got Denim. Over here. There it is. Alright, no, hang on. No, that's where we need to go. There it is. It's pretty dark. Another big gas giant, 20% more massive than Jupiter. It has a very inclined axis. It has a small moon and a major moon. Excellent. And this means shade of blue, Denim. Oh yeah. Next one out. Ooh, this is a bizarre look, isn't it? Ooh. A small frozen moon covered in solid carbon dioxide and sulfur dioxide, giving it a red colour. I think this atmosphere is looking a bit funky. It's not like fully, the elements maybe aren't fully spread. I don't know, it's a weird look. So this means purple redness. And the next moon gurges here. Thick atmosphere composed of mostly methane as well as ammonia. On the surface is covered in ammonia, ice and methane oceans. Has a retrograde orbit. It means abyss and flood. There it is underneath. You see the oceans. Very nice. Good stuff. Okay. Now moving on to Magnus Gello. Over here. It's getting pretty dark. I have to go on that flashlight mode. There it is. A frozen and dense super-Earth, being more than 5 times the mass but only 1.6 times the radius. It's covered in an ice and has a nitrogen atmosphere. It has icy rings and a major moon. Good stuff. And this name means big freeze. Oh. Then we have small freeze. Like its host planet, covered in ice, but instead of being just water, it's 100% or 10% composed of sulfur dioxide. It has a retrograde orbit as well. Okay. Good stuff there. There's the little rings. Nice. Right, moving to the next object, we've got Gigaspheri. Is this a big planet by any chance? Oh, there's a lot of reading. Oh, there it is. A massive planet, 11 times the mass of Jupiter, but curiously it's not a gas giant as it's composed of silicates and iron, and mostly in liquid form. It got its composition from clearing out a big portion of the asteroid belt and 2 small moons and 2 major moons. It means gigantic iron. Hey. Nice. Let's a good look at it. Cool. Alright, next up hang on. We're missing one? No, let's go this one first. Ostram here. About twice the mass of our moon. It's probably the most beautiful object in the system. It has a purple atmosphere composed of all sorts of materials, as well as pink clouds. The surface is mostly covered in ice that hides oceans composed of sulfur dioxide, water and ammonia. It supports exotic life, like dark red plants to absorb light from the distant blue star, some of which have adopted bioluminescence. And the name means purple. Ostram. Nice. Looking good. How does it look on the realistic lighting? Oh, it's pretty dark. Not receiving much sunlight anymore at this distance. Oh, yeah. Oh, goggles lighting. Oh, flashlight back on. There we go. Right. So, next up we got this one. This one means choke. Obfoko. A very toxic world. Has a thick atmosphere of sulfur dioxide and carbon dioxide that traps all the heat from the star, making it nearly 100 degrees while orbiting over 110 AU from its star. Okay. 110 AU from the star? It must be. Is it? Well, this is on the planet, isn't it? Yeah. Okay. So, what was the pass? So, we're looking at gas giants. 133 AU. Oh, it's quite the distance. So, yeah, alright. So, this one maintains the heat. Interesting. Okay. Then we have... So we've done that one. We've got Plagules next. Where's that one? We've just done that one. Plagules. I don't see one called that name. Is that this one? Plagos? Argonis? I'm guessing it's this one. Argon rich well. The element is present in all states, gaseous in the atmosphere, in liquid oceans at the equator, and in the soil, and solid at the poles. There it is. I think it's related because it means argon, even though it's called Argonis. And here it says Plagos. I think that is the same object. And then lastly we've got AorHidis. Nearly the same mass as Earth, but only half the radius. It has a very strong gravity and fast rotational period of 10.5 hours. Under the argon and methane ice, it hides an ocean of the same materials, which probably holds some exotic life. It orbits far away from its host planet, taking more than 3 months to complete an orbit. Oh, wowee. Okay. It's quite the orbit time. Okay, next up. So, we're taking a jump past the last asteroid belt. I think there was one, wasn't there? Yeah. Then we're taking the jump all the way over to the Fallacia subsystem. This was probably its own system before being captured by the gravity of Sulfur, as it doesn't share the abundance of sulfur and the rest of the system. Okay. So, deceit and... So this is Fallacia? Deceit and trick. Does that mean it is a fake star? So it's a brown dwarf? I'm guessing. No, it's a red dwarf. It has a very low temperature and luminosity and takes over 20,000 years to orbit the main star. Its red light hides the true colours of its orbiting planet. Ooh. There it is with the lights off. Very, very bright. So, first up we have got Vapos here. So you can see it's getting its light there. Turn the flashlight off. There's the true look. The only gas giant of this subsystem. It's very hot over 400 Celsius and takes 21 hours to orbit the star. Okay. And the glare of the red dwarf. Next up we have got Adventa over here. A dwarf planet. Has a very elongated orbit, as it is most likely a rogue object being captured. Okay. There you can see the orbit actually. I had a brief look at it before we came in. There it is. That means stranger or foreigner. Okay. This one meant steam and smoke. Vapos there. Over here we've got Second Home, also known as Beta Domus. A dwarf planet. Has a... Oh, hang on, no. The only Earth-like planet. It has 20% mass of Earth, but has a similar surface gravity. It has a slow rotation, meaning its year is equal to 2 days. It supports life as we know it, but the plant life has evolved to be a darker colour to absorb more light from its dim host star. So if we look underneath, there's a look at it. If you put flashlight on, there's a better look. There you go, looking good. Goggles on, off. There you go. Composition stuff. Let's have a look at its stats. 81 and 2. Yep, it's got got all it needs. There you go. For a very dim light from the host star. Let's get a little surface view here. Let's see what it's all about. So we look around. There it is. There's your sun. Turn that all off. And there you go. Very, very faint light. Probably would be pretty beautiful to observe. Let's go a little further north. So under that atmosphere we can see there's a nice little sunrise kind of going on for you there. Hey. There you go. Looking good. There you are. Below the atmosphere haze, get the real difference. See the old gas giant there as well. Look at that. Hey, so that'll be definitely reflecting some light in the sky there for sure. So look with the goggles on and off. Yeah, look at that big difference. Very cool. I like it. Awesome. Next up, we've got Celadon, which is here. The biggest rocky planet of the entire system has 6.6 times the mass of Earth, has a green atmosphere composed of various elements as well as a mostly green surface. It holds liquid helium and hydrogen beneath the surface while not being very cold. It has one moon. It means shade of green. And the moon here, very dark. It is believed to have been generated after a collision between Celadon and another object due to the similar composition with its host planet. Nice, and that is everything. I say I really enjoyed that. There it is. Excellent. I like the hidden meanings behind the names in the description. That's quite a cool use of the new like object descriptions here. That's a really cool use of having that hidden meaning of the names. That's cool. I like it. Very well put together. I like the menu. How we have to click next for each planet. It really helps with navigating the system as well. So thumbs up from me for that. I do like that. Let's see if there's any hidden secrets. That looks to be everything. There we go. That is it. And he also said the system runs. So let's give it a go. Let's see it in action. There you are. Let's see. Is it going to work? Yep, there it is. So it all properly runs. We like a system that runs. Obviously quite slow. If we remove the ring particles, you get way quicker speed. So there you go. Always like a system that runs. Bit of a wobble over there from Magneskello. What's the cause of that? Well, that moon giving it that little wobble. Look. Hey. There you go. Very nice. So let's get the full lineup of everything. And there you are. Looking very good. Oh, very bright. So there you go. That's everything. I did like the design of the gas shunts in there. I thought they were very unique designs. All look pretty cool in their own right, I thought. There you go. As for the rocky objects, there you go. Looking good. There's that very hot object as well. Nice. Yep. Thumbs up for me. Really enjoyed that. So again, a massive thank you to the creator of this system, Italian Jesus, send this in. Really enjoyed that. I thought that was really good. So yeah, if you guys enjoyed it as well, press that like button down below. Let's see if we can get 100 likes on today's video as well. And also subscribe for more. Help us on the journey to 50,000 subscribers. And yeah, everybody, have a great day out there. Stay safe. And I will see you in the next video. Goodbye.